In this session, we will learn how to control network traffic in a transit gateway by using the transit gateway route table. While a transit gateway allows communication between multiple networks, you may want to restrict access to certain IP ranges or allow traffic only to specific destinations. In such situations, you can use the transit gateway route table to define custom routes and control traffic flows between networks. First, let's move to the VPC menu from the console. From the VPC menu on the left, go to Transit Gateway Route Tables. Select the route table, then click on the Routes tab at the bottom. You will see the static routes we configured. Let's try blocking traffic, which is going to VPC02. Select the static route for the CIDR block 10.2.0.0/16, which is VPC02. Then, on the right side, click on Actions and choose Replace Static Route. The menus and options are the same as the one we used when we initially added this route. This time, instead of selecting a target attachment, we will choose the type as black hole. When you select black hole, the option to choose an attachment disappears. This means the traffic to this destination will be dropped. Now click Replace Static Route at the bottom. Back on the Transit Gateway Route Table screen, you will see that the route state for the 10.2.0.0/16 is now set to black hole. This means that any traffic going to this range through this Transit Gateway Route Table will now be blocked. Let's switch back to the PuTTY and test this. From the VPC01 private instance, type ping and private IP of VPC02 private instance and press Enter. You will see that there's no response. Type ping and private IP of VPC03 private instance and press Enter. This time, the communication works as expected. Now switch to the VPC02 private instance, type ping and private IP of VPC01 private instance and press Enter. There's no response as expected. Type ping and private IP of VPC03 private instance and press Enter. There's no response as expected. Lastly, switch to VPC03 private instance. Type ping and private IP of VPC01 private instance and press Enter. The communication works. Type ping and private IP of VPC02 private instance and press Enter. There is no response as expected. So now, communication between VPC01 and VPC03 is working, but access to VPC02 is blocked. Now, if we want to allow communication only to a specific private instance inside of VPC02, how can we do that? Let's go back to the Transit Gateway Route Table and, in the Routes tab, click on Create Static Route. For the CIDR block, we will enter the private IP address of the VPC02 private EC2 A1. From the search bar, type EC2, right-click and open in a new tab. Move to the instances. Select VPC02 private EC2 A1. Copy the private IP. Go back to the Transit Gateway Route Table screen, paste the private IP and type /32. By adding /32, we're specifying a single host IP address, which effectively means we are targeting the specific instance only. Next, set the type to active. Then under Attachment, choose VPC02 attachment and click Create Static Route. Go back to the Route Table screen, you will see the static route we added. Let's switch to PuTTY and test again. From VPC01 private instance, ping to VPC02 private instance and press Enter. This time it works and the connection is successful. And ping to VPC03 private instance and press Enter. This also works, just as before. Now switch to VPC02 private instance. Ping to VPC01 private instance and press Enter. Now it works. and ping to VPC03 private instance, and press Enter. This also works just as before. Now, switch to VPC03 private instance. Ping to VPC01 private instance and press Enter. It works just as before. And ping to VPC02 private instance and press Enter. Now, it works. And that concludes the chapter. Over the last 2 chapters, we learned how to connect multiple VPC networks using both VPC Peering and Transit Gateway. When building a real AWS cloud network, the choice between VPC Peering and Transit Gateway depends on your system's architecture, application needs, and cost considerations. While Transit Gateway can be more expensive than Peering, it offers centralized routing and simplifies network management. So even though there is a cost difference, the operational advantages of Transit Gateway may justify that cost, depending on your situation. There's always a trade-off between these options. What matters is selecting the right one based on your application, system design, and overall resource planning. In the next chapter, we will configure a site-to-site VPN to connect your AWS network with an external network.